Hello friends, this is Dr. Mohammad Aslam FCA from Pulse Tutorial. In our previous videos, we discussed partial least square structural equation modeling PLS for basic reflective model building. Today, we will discuss PLS for an extended reflective model building. Smart PLS3 software is used for today's discussion. Let's set a file with license key and working files link provided with this video for your download and use. You can contact us by email, Zoom, or WhatsApp for any further assistance. The PLS seems hotcake for social science research recently. It has been used widely in latest articles published in high-quality journals such as Web of Science and Scopus. Because it can deal with multiple variables containing multiple indicators or items for factor analysis and regression simultaneously. It is termed as third generation statistics for social scientists. We emphasize its applicability rather than technicality and used hypothetical theory and dataset for your easy understanding. Let's discuss PLSM extended reflective model building and reporting with multiple variables and multiple indicators or items. Say you find from the previous literature that organizational learning and corporate culture cause impact on organizational performance. It means earlier theory established that better organizational learning and corporate culture had significant impact on better organizational performance. Appropriate reference need to be given for this theory with citation. For example, Aslam et al. 2021 generalized this phenomenon. Now, we want to explore this theory either to confirm or reject with our research work and data. Here, we get three variables. Organizational learning as independent variable observed through OL1 to OL8, where OL1 means basic learning, OL2 means professional learning, and so on up to OL8. Corporate culture as one more independent variable observed through CC1 to CC6, where CC1 means formal culture, CC2 means supportive culture, and so on up to CC6. Organizational performance as dependent variable observed through OP1 to OP5, where OP1 means in-house performance, OP2 means communication performance, and so on up to OP5. In PLSM, independent and dependent variables are referred to independent and dependent constant. A particular constant is observed or measured through reflective or formative indicators or items. This discussion is for reflective indicators. It means related observed indicators reflect the unobserved construct in the study. More indicators or items supported by literature can make comprehensive measurement for the respective independent or dependent construct. Let's assume our research is based on primary data. After setting the aforesaid indicators for independent and dependent construct, we need to prepare questionnaire for data collection. Here, we use 7-point Likert scale for respondent score. How to entry data in Excel sheet from filled up questionnaire and then transfer to CSV format for Smart PLS data read are discussed in our previous video, Basic Reflective Model. Hope you have seen the videos and practice those working files for your basic understanding. Please open your installed Smart PLS3 software. The interface will be like this. Click on New Project and name it as PLS SEM Extended Reflective Model. Press OK. We'll find newly created project in the Project Explorer here. Then I will double click this data to import. This is our CSV format file that has discussed in previous video. I open it, I OK it. So we find the data set and it reads green. PLS SEM extended reflective model data text file provides that shows reports for indicators, indicators correlation and row file, indicators, indicator correlations and row file. All 21 indicators S gender, OL1 to OL6, OL1 to CC6, OP1 to OP5 are shown serially with no missing data. Serially with no missing data. Then we find mean, median, minimum, maximum, standard deviation, excess kurtosis and skewness. Although PLS-SEM is a non-parametric test where no need to assume normal distribution, but even we want to know our data characteristics. We know that perfect normal distribution contains mean 0, standard deviation 1, skewness 0 and kurtosis 3. Acceptable value of skewness fall between -3 and +3 and kurtosis is appropriate from the range of -10 to +10 when utilizing SEM, Brown 2006. For this reference value, we see that our data are more or less normally distributed, which is a safer side for the researcher. This is. This indicator correlations gives primary relationship among them and raw data file exactly the same data entered in the earlier Excel file. Now we go for PLS-SEM extended reflective model. PLS-SEM analysis was performed to assess the relationship of OL and CC with OP. This example studied whether organizational learning and corporate culture cause effect on organizational performance. Research objective 1. To find out whether organizational learning causes organizational performance. Research objective 2. To find out whether corporate culture causes organizational performance. With this research objective, we set the two alternative hypotheses. Alternative hypothesis 1. Corporate culture causes organizational performance. CC to OP. Alternative hypothesis 2. Organizational learning causes organizational performance. H2. OL to OP. First, we prepare measurement model to check whether the model is fit for further analysis. If it is fit, then we prepare a structural model to find out ultimate research objective, that is the relationship among construct with their respective significance level. Let's build our model with our dataset. We need to double click on the figure icon just below our PLS Extended Reflective Model project in the Project Explorer. Double click here. It shows the empty canvas. We ignore it for the time being. Now we drag the item from here. This is indicators. OL1 to OL8, drag it here and rename it OL. Okay. Then we drag data CC1 to CC6, drag it into the canvas and we rename it as CC. We align it and align indicator top. That will be convenient for us. Then we take our dependent construct OP, drag it to the canvas, rename it OP and align it to the right. Now we adjust the zoom as per our convenience and drag it. Now we connect the data from connect tool. This is OL to OP and then CC to OP. We neutralize the cursor by selecting select. Made a little bit design. Okay, perfect. It turns green, it means it's ready for run. Now we'll build the measurement model. We select calculate option, PLS algorithm. We go for factor, then we start calculation. It will take a little while to give the report. The report is ready. We find PLS algorithm run one for measurement model with main column, final result, quality criteria, interim result, and base data. Under this subcolumn, we find our specific required values, outer loadings, construct reliability and validity, discriminate validity. For reporting in the following measurement model, we get figure 1 from PLS SEM extended reflective model SPLSM, that is this one. Then we right click it and export image to the file, to our destination file that I have done earlier. Okay, so in this way we get this figure. You can see this figure and this figure are same. Now from PLS algorithm run one, this one, we get our outer loadings from here. Now from this we can copy to clipboard Excel format and we can paste it over there in an Excel file. We paste. You see it is the same thing. So I delete it. In the same way, we can copy reliability and validity. This is constant reliability and validity. Copy, and here we can paste. In the same way, from the software to Excel sheet, we can transfer all the value. In this way, I have transferred outer loadings, reliability validity, discriminate validity, Cornell Larker criterion, discriminate validity cross-loading, discriminate validity STMT ratio, everything I have copied from the software to the Excel for the reporting purpose. Now we'll check this value. First, factor loadings. Here is the factor loadings. From the Excel sheet we have input in the Word file. We see the factor loadings. It is all the threshold value is 0.6 and these are all above 0.6. So we retain these values. For construct reliability, we find this figure, Cronbach's alpha, rho alpha, and composite reliability. We put the figure here, and all are correct with their threshold value. For constant convergent validity, we need the average variance extracted. This is the value. We put it here, and it is also above 0.5. For discriminant validity, this one, first we need cross loadings. First, we need formal local criteria. This is the criteria. You see, these values are here, and all the diagonal value are greater than these values. So it is valid. Then discriminant validity cross loadings. I will got it here. These are the values of the cross loadings, and you see the respective values are more on their individual construct rather than the other construct. It is termed as bold. So this validity is also done. Another criteria is STMT ratio, which I got here. This is the values. So the decision is yes. Finally, this model is more or less fit for further analysis. Now let's go for the next step, that is structural model. After clicking the SPLS file, we go again calculate bootstrapping. Now we select no sign change, complete bootstrapping, bias corrected and accelerated bootstrapping, two-tailed test and 5% single test level. Then we start Calculation after selecting path. Now we are taking path. Start calculation. It will take a little while. The calculation is going on. Okay, done. It has given us the report, bootstrapping report. Now we go to the figure again and we find that our bootstrapping report is created. Now from this we select for inner model path coefficient and p-values, for outer model blank, and for highlights path we use absolute values. So it will make us understanding the figure better. Now right click, export image to file. We can export it to our destination file like this. Okay. Now we find this figure and this figure are same. Now we will analyze this. At first, we'll find out the R square value. The R square value we'll find out in bootstrapping R square. You see the R square value is 0.385 like this, which is put here 0.385. The significance level is it is statistically significant. So it means 38.5% variance can be explained by organizational learning and corporate culture for organizational performance. Now we go for path coefficient. In the same way, we can copy this file and transfer to the Excel as we have done before. So I'm not repeating that. This is path coefficient. These are the values which is put in this table. You see, this is our alternative hypothesis 1. This is our alternative hypothesis 2, which is this is in software. And this is the respective values. Our first p-values is almost greater than 0.05, so it is rejected, and the second one is accepted because the p-value is less than 0.05. So our alternative hypothesis number 1 is rejected and number 2 is accepted. Now we go for the decision. First, we see the first alternative hypothesis is rejected. It means corporate culture did not organize organizational performance, but it could be partially significant as the p-value is less than 10%. The beta coefficient sign is positive, means the positive relationship between the culture and performance. Corporate culture and performance, the beta value is positive. The more culture associated with better performance and the value 0.0230 with partial statistical significance means 1 unit change in culture could cause this unit change in performance. Based on this model, a particular entity should be involved more in building corporate culture in the environment to achieve better performance. Second alternative hypothesis is accepted. It means organizational learning cost organizational performance. This we see, this is the beta coefficient, this is the significance level. Now we are interpreting it. The beta coefficient sign is positive, means the positive relationship between learning and performance. The more learning associated with better performance. The value 0.431 with statistical significance means 1 unit change in learning could cause 0.431 unit change in performance. Based on this model, a particular entity should be involved more in achieving organizational learning for achieving better performance. So this is our extension model with 2 independent variables and 1 dependent variables. I hope you enjoy it. All the study materials are given with this video. So you can get the data set and discussion and figures, everything. Thank you for your time. I think it is helpful. Goodbye.